What we have here is a problem showing a linear function, that straight black line, and a quadratic function, which is, there's blue and red parts to it. I just colored them differently so you could focus on which portions are above and which portions are below the black line. And what we're told is we want to rewrite an inequality. In other words, this thing right here. Focus on this. This is the very first thing to look at in this problem. In this case, I want to draw your attention to the fact that it is an inclusive equality. I wrote that inclusive right here, which means we're going to be using square brackets and we're including the intersections between these two lines. There's another version of this problem which is exclusive. I'll do that one next. It's just going to be a slight modification. But when you have an exclusive problem right here, that means greater than, not equal to. So we will not be considering the intersection points there. So I'll do this one first. The second part will go quickly once we get our work out of the way. The equation of the linear function is the very first thing I want you to consider. And if you notice, it looks like y equals x. Okay, I could say y equals x. I'd be a little bit wrong because y equals x actually looks like this. Okay, it goes through 0. And this one is shifted downwards by 1. So this would actually be x minus 1. That's the way to figure this out using transformations. If you want, you can also think in terms of y equals mx plus b. Figure out the slope, figure out the y-intercept, and so on. Whichever you're more comfortable with, honestly. That's the right way to go. So we have our linear equation, y equals x minus 1. And now we want the quadratic equation, this guy, g of x, which is also y equals something. And I'm going to use vertex form because I find that very easy when talking about transformations. This is going to be some kind of x squared. Looks like a negative because it's going down, right? This thing is shaped downwards like that, so that's going to be some kind of a negative. So I have the negative, and then inside the parentheses I have x minus 3 squared and plus 4. Well, how did I figure out x minus 3 and plus 4 so quickly? I'm looking at the vertex of this thing. The vertex is located right here at 3, 4. 3 in x, 4 in y. So that's how I figured out so quickly that it's going to be located at x minus 3 squared plus 4 as the equation. So there's our equation work out of the way. And now I want to rewrite these two equations in inequality form. So in other words, x minus 1, that's f of x, greater than or equal to negative x minus 3 squared plus 4. That's it. That's this part. I've rewritten it as an inclusive inequality. And now we have to solve it using interval notation. Well, solving this thing only takes a little bit of work. First, let's convert it into standard form. So I'm going to say this is x minus 1 on the left. There's not much to do there. And then I'm going to expand this part out. So I'm going to first do x minus 3 squared. I'll say, well, that's just x squared minus 6x plus 9. I didn't forget the negative on the outside, and I didn't forget that plus 4 over there. And now, if I eliminate the parentheses and combine like terms, I'm going to have negative x squared, looks like plus 6x, and then minus 9 plus 4, that's going to be minus 5. Okay, so now the right side is simplified. And now what I'm going to try to do is move everything over to one side. And because this negative x squared is on the right, I think negative x squareds are a pain in the neck. So I'm going to move that over to the left side by adding. I'll have an x squared on the left. I'm going to subtract 6x over. So this gives me now x minus 6x. That gives me 5x. And I'm going to add 5. So negative 1 plus 5 equals plus 4. And if I want to, I have to keep that inequality there. So this is going to be greater than or equal to 0. And now I turn the left side into factored form. And I think we'll be ready to finish this up at that point. So this is going to be x minus 4 and x minus 1 greater than or equal to 0. Now, in class, we went over building a sign table. And the way a sign table works is it's very easy. You just build a table like this. And you put your x-intercepts down here. And my x-intercepts are 1 and 4. And now you put your factors over here. So x minus 4 x minus 1, doesn't matter the order you put the factors in, but you have to know where they're positive and negative. So x minus 4 is going to be positive above 4 and negative below 4. So negative, negative. And x minus 1 is going to be positive if you're above 1 and negative if you're below 1. And now we multiply these things together in the vertical direction. So this becomes positive, negative, positive. And that right there tells me what the inequality solution is going to look like. So remember, I'm looking for greater than or equal to 0. So how do we solve that? Well, what's greater than or equal to 0? It's this stuff and this stuff. In other words, I wrote 8. Give me a break here. Negative infinity all the way to 1, including 1, because equal to 0 is okay. And then union, where else is it positive? Well, starting at 4 and going all the way up to infinity. Now that's using a sine table method. I'm just realizing now there's a much easier way also. If you look at the graph, let's look at the graph here. Where is the straight line bigger than the curvy line? Well, it's all this stuff and all this stuff over here. See, that's all where the straight line is bigger than the curvy line. And here's the intersection points. At x equals 1, x equals 4. Okay, great. Now let's draw a number line. So a number line version of what I just wrote, the negative infinity to negative 1, or to positive 1, is going to look like this. I'm going to use the dots to put my inclusive parts right there, 1 and 4. And then I'm going to come over here and click on this line tool, the ray tool, and draw arrows that go like this. Okay, and that will be that. That'll be the solution to this problem. Now, the other version of this where I said, oh, well, what if you got an exclusive version, right? What if your inequality sign was greater than not equal to? Well, now, take a look at this graph. Again, it's still going to be these regions out here that we're talking about. But now we do not want those intercept points. So those are going to be holes right there, or open circles. So the way we're going to say this is negative infinity. Again, it goes to 1, but it's a curvy parentheses because we do not include 1. Then we pick up again at 4, and we go out to infinity. And the way you do this on the number line is you pick that open circle marker, and you say right here and right here. And now you go pick your ray marker, and you draw those rays going out to infinities.